Okay, I can't tell if it's quite in focus, but this was the easiest way that I could think of to help. So we've got our northern, I'm going to call it axis here because that's really what it is. And we assume that at the beginning of the problem, both planes are flying due north in formation. Then we have a plane, let's say plane A, breaks off at an angle, at a bearing of 22 degrees, which later in the problem it tells us is a non-negative number between 0 and 360 counterclockwise from the northern axis. So what that means is the airplane A breaks off at an angle of 22 degrees as shown here. Then we have airplane B, which breaks off at an angle of 87 degrees. So I'm just going to do the addition really quick. Let's see, 87 minus 22, 65. 65 degrees. So the sum of the two angles there is 87. That's just the easiest way for me to draw it. So this is plane A, and this is plane B. Now, what we need to do is we need to, given the information at hand, find the rate of change of this side of the triangle in miles per hour. So what that means for us is a couple of things. It means that let's call the point where they break off the origin. So what we can do is, since we know that we're going to be looking for the distance, the rate of change of the distance between the two planes at the time 1/4 hours, 15 minutes, I did the conversion up over here, then we can know the length of the line OA, O being the origin. So for plane A moving at 130 miles per hour, we can do, here let's do OA is equal to, that just denotes vector, which isn't essential, but is just how I'm annotating that it's this line. So for line OA, the length is 1/4 hours times 130 miles per hour, which is equal to 134th miles. You can use a calculator, obviously, to get a number that actually means something there. And then we can do the same thing here. The length of the line OB is 1/4 hours times 96 miles per hour, which is equal to 96/4 miles total. I'm writing it with the units so that we can make sure that our math is correct. So, given that, we can find the length x, but more importantly, we can model the length x as a function of the angles and the lines so that we can take its derivative. That's probably all I'm going to do for this first chunk. I'll send it to you, and once I've actually figured out how I want to model this, I'll let you know. So 1 second.